Welcome viewers, welcome to the new lesson from Dr. R's Biology. If you did not subscribe the channel, you can just click on the subscribe button and bell icon.
Dear students, ensure that you have watched the part A of Unit 4 Topic 2 before watching this particular lesson, because stage 1 and stage 2 of glycolysis is discussed there in that particular lesson. Then only you have to come here and watch this particular lesson.
Now let us move to the stage 3, step 6 onward, step 6 to step 10. Okay, stage 3. And step 6, step 4 and 5 belongs to stage 2. So for that purpose, I just need a glyceraldehyde 3-phosphate only. From this point onwards, you have to keep in mind that two molecules of glyceraldehyde 3-phosphate will be involved. Why? Because we know that the dihydroxyacetone phosphate that is already formed is converted to glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate already directly formed from the fructose 1,6-bisphosphate. In addition to that, the dihydroxyacetone phosphate is already converted to, it's also converted to glyceraldehyde 3-phosphate. So from this point onwards, every molecule that we are representing will be 2 in number. Even though if we are not specifying it, it will be 2 in number. Ensure that. Okay. So next step 6 is the oxidation and the addition, phosphorylation of the glyceraldehyde 3-phosphate. Let us see what it will be happening in 2 steps. Anyway, I will just draw the first step there. So glyceraldehyde 3-phosphate is converted to, glyceraldehyde 3-phosphate is converted to 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate. Remember, you have to draw it down only. Okay, hope you remember that. And what is the enzyme that catalyzes this reaction? I will show you something, and after that you just try to tell what will be the enzyme. Okay, here glyceraldehyde 3-phosphate is undergoing 2 processes. First one is oxidation. Second one is phosphorylation. Okay, the first one is oxidation. So oxidation should happen to glyceraldehyde 3-phosphate. Okay. If oxidation should happen, what should be the? That should be an oxidizing agent. That should have an oxidizing agent. So oxidation and reduction is happening at the same time. It will be a redox reaction. So what will be the enzyme? The enzyme that belongs to which class? Yes, it is nothing but the oxidoreductase class. It is otherwise known as dehydrogenase. So what will be the enzyme? Glyceraldehyde 3-phosphate, 1,3-bisphosphoglycerate dehydrogenase will be the enzyme. I am just writing dehydrogenase only. Okay, dehydrogenase enzyme. Now we can see that what will be the oxidizing agent should be there. We know that NAD plus is an oxidizing agent. As a result, what is happening? NADH plus H plus is happening. H plus is happening. Now, what should be added? You can see that one more phosphate group is added at the first position. So phosphate group should be there. Whether we need ATP. We don't need ATP because already an energy is released due to the oxidation. So that energy itself will be fine. So we don't require any ATP molecule. Instead, we just require an orthophosphate only. So we will be just adding one phosphate group, that Pi. Pi will be entering, and that Pi will be added. So you have to remember that why ATP are not used even though a phosphate group is added to the first position. It's because it's an oxidation step, and that oxidation is along with the phosphorylation. Clear? So let us see the structure. We know glyceraldehyde 3-phosphate. So CHO, CHOH, CHHOPO3, 2 minus. And what is there? We will be just adding Pi, that is nothing but OPO3 2 minus. Okay, Pi is nothing but OPO3 2 minus. And what we require? We are having oxidation step. Okay, and the NAD plus should be there. NAD plus should be there. So I'm just changing the CHO into a different pattern. Okay, so C double bond CO, and I'm just writing this one with this blue H, in order to show you from where the hydrogen of NADH comes, from where the released hydrogen of NADH comes and all. In addition to that, we need one H2O also. So I'm just writing H2O in the form of HOH. Clear? This H2O only to show you how the hydrogen and oxygen hydroxyl group are moving from water. I'm just writing it as HOH. Now NAD. So there will be NAD plus also. That is entering. Okay, let us see the product that is formed. The product is nothing but this OH will be added to this particular portion. So C double bond O, and then it will be added to the OH. I took a break to receive a parcel. So where we stopped? So we can see that this is a reaction that is in the step 6, where the glyceraldehyde 3-phosphate is converted into 1,3-bisphosphoglycerate. We can see here this OH is added here. Now if that OH is added here, where this H will be coined. Okay, make sure that you are drawing the structures at the end of this particular step only, because I will be explaining how all these things are coming, and the step you can just represent only at the end. Okay, because I will be changing. So this hydrogen is moving to this particular NAD. Where this hydrogen will be moving, it will be moving as NADH plus H plus. Okay, so we can just draw that also there. Plus NAD. So this H plus came from this H, and now NADH is there. That H came from here. So this glyceraldehyde lost one proton, one electron. That's why it is known as the oxidation step. Now Pi added. We know the structure of Pi. What is Pi? Phosphate, double bond O, OH, OH, OH. We know that this hydrogen will be removed to ionization because it's acid, and that's why we are just making it 2 minus, and one oxygen will be involved in bonding, that is this oxygen. Okay, in the same way this also will be formed. Okay, now you can see that I'm just releasing water also. In addition to the NADH, this water also will be released. In that OH is from the phosphate, and OH is from this particular thing, and H is from this phosphate. This H will be there. So you can see here In addition to NADH plus H plus, what will be formed? HOH, that is water is formed. This OH. Okay, so finally, ultimately what happened? By releasing this OH, phosphate group is added. I am just showing that. Till now I did not add phosphate group, just to show that where this OH and coming here and there and all. Okay, so I am just repeating the point till now. This particular step is actually happening in two-step process. The first step is the oxidation and second step is the phosphorylation. In the oxidation step, the high water, with the help of water molecule and NAD plus, oxidation takes place. As a result, COOH, what will be that particular thing? Glucaric acid. You know it. Okay. Glucaric acid is the glucaric acid will be then undergoing phosphorylation. As a result, this OH is removed and phosphate group is added there. As a result, glyceraldehyde 1,3-bisphosphate is formed. So first step, oxidation results in glucaric acid, and the glucaric acid undergo phosphorylation to form the glyceraldehyde 1,3-bisphosphoglycerate. So you can see here, this OH I am just changing into OPO3 2 minus, OPO3 2 minus. Okay. Now the remaining portion will be same, CHOH, CHHO, PO3 2 minus. So water entered here is not the same water that is left. Okay, only this OH is same. The hydrogen is actually from the phosphate group. So this is the step that is forming the glyceraldehyde, 1,3-bisphosphoglycerate. Clear? So you have made glyceraldehyde 3-phosphate into another high energy rich molecule, because phosphoryl transfer potential is there. 2 phosphoryl transfer potential is there with the bisphosphoglycerate. That is actually forming the ATP molecule later. Clear? The 6th step is there. And ensure, I told you before, now onwards it is 2 molecules of glyceraldehyde 3-phosphate and 2 molecules of 1,3-bisphosphoglycerate is formed, 2 molecules of NAD plus involved, 2 molecules of NADH is formed, 2 PI will be added, 2 water will be added, and 2 this thing will be formed. So entire thing will be 2. Now you can just copy the figure. Clear? That's about the 6th step. Identify and understand what is happening, and then you just learn it. Clear? Simply we can say that step 6 is nothing but glyceraldehyde 3-phosphate is converted into 1,3-bisphosphoglycerate, where oxidation and the phosphorylation happens to glyceraldehyde 3-phosphate. It is with the help of dehydrogenase enzyme and with the utilization of NAD plus water molecule and PI, where NADH plus H plus water molecule is released out. Let us move to the next step, step 7. I am just moving to the step 7. That also comes under the stage 3. Step 7. So I forgot. I can just make it. Anyway, you are also drawing, I am also drawing the same thing. So I am just drawing what happened. 1,3-bisphosphoglycerate. Glycerate, it's not aldehyde, it's acid. Glycerate, glyceric acid, that is otherwise known as glycerate, is now converted. All these reactions are reversible only. Okay, all the above reactions except step 1 and step 3, it is not irreversible, it is reversible only. Step 1 and 3 only is the irreversible reactions. Now 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate. What happened? The 1-phosphate group is removed. And who will be receiving that phosphate group? It is nothing but the person who is ATP. So when you are having double arrow mark, make sure that you are writing in the correct arrow mark, because we can see that in this direction ADP will be accepting the phosphate, forming ATP. And if you are just drawing the ATP here in this direction, which is actually the arrow mark in this direction, that is wrong. Ensure that you are marking all the changes in the appropriate place. Okay, so don't interchange it. So ADP will be converted into ATP. Now who will be the enzyme? Definitely phosphorylation is happening. So phosphorylation happens means what will be the enzyme? Kinase will be the enzyme. Now the question is, what kinase? It is nothing but phosphoglycerate kinase, because we can see the opposite direction. Phosphoglycerate is getting a phosphate group from ATP and forming 1,3-bisphosphoglycerate releasing ADP. The opposite direction you have to think, even though we are discussing glycolysis in this direction, to name the enzyme kinase, we have to think in the opposite direction. Okay, so this enzyme is phosphoglycerate kinase. So PG kinase, phosphoglycerate kinase. Clear? Now we can see that normally phosphate group is the one which is donating, ATP is the one which is donating phosphate group. But here what happened? Substrate other than ATP donated the phosphate group, and that even to the ADP molecule forming ATP. What kind of reaction is this? This kind of reaction is known as substrate level phosphorylation. Okay, remember this particular thing, substrate level phosphorylation. You will be getting 2 more questions. Substrate level phosphorylation. So what is substrate level phosphorylation? It is a reaction, phosphorylation reaction, where substrate other than ATP molecule becomes the donor of phosphate group, and it results in the production of ATP. Okay, that kind of reaction is known as the substrate level phosphorylation. Example is this one, and there are upcoming reaction also that also form the ATP. Okay, so this is substrate level phosphorylation, where 1,3-bisphosphoglycerate, 1,3-BPG bisphosphoglycerate is converted into 3-phosphoglycerate with the release of ATP molecule. Now the question is, how many 2 molecules of 1,3-bisphosphoglycerate is involved in this reaction, and therefore 2 molecules of 3-phosphoglycerate will be formed. Definitely 2 molecules of ADP will be entering, and definitely 2 molecules of ATP will be released. Okay, so let us see the structure. So we have a 1,3-bisphosphoglycerate. So C double bond O, OPO3 2 minus, then CHOH, and CHOH, CHH, and OPO3 2 minus. So this is actually what? 1,3-bisphosphoglycerate. That is converted to, it is a reversible reaction, that is converted to 3-phosphoglycerate. So what should be the, this should go out. Okay, so 3-phosphoglycerate, C double bond O, OH came here. 3 double bond O, OH came here. Now C H OH, and then C H OPO3, we will be writing it later. OPO3 2 minus. What happened in between? ADP molecule, ADP molecule accepted that phosphate group and changed into ATP. Repeat the enzyme name here, phosphoglycerate kinase. Hope you got the idea. Okay, now the question is ADP, from this, where this particular OH came, from where that particular OH came. Okay, it is from nothing, where this oxygen plus the hydrogen of ADP, final ADP. At the end of ADP you will be having OH. Okay, that H plus this oxygen is actually this OH. Okay, so this is 3-phosphoglycerate. Is an example for substrate level phosphorylation. Now let us move to the step 8. In step 8, a mutation is happening to which molecule we learned last time? A mutation is happening to 3-phosphoglycerate. What we will be calling as a mutation? We know that in case of the DNA, if any nucleotide is lost or if any nucleotide is changing their position, it will be known as the mutation. So that kind of change in position is happening to phosphoglycerate. As we are just calling it as a mutation, what will be the enzyme responsible for that? We know that lipid digesting enzyme lipase, protein digesting enzyme protease, the amylose digesting enzyme amylase. In that way, mutation inducing enzyme, it will be mutase. So phosphoglycerate mutase will be actually catalyzing a reaction where a change in position of the phosphate group in phosphoglycerate is happening. So the 3-phosphoglycerate will be converted into 2-phosphoglycerate. There is no involvement of other molecules in it. It's just an isomerization reaction where the phosphate group is just changing from the third carbon into the second carbon. So 3-phosphoglycerate is converted into 2-phosphoglycerate. That forms the 8th reaction in glycolysis. So let us see that particular reaction. So this is nothing but 3-phosphoglycerate is reversibly converted into 2-phosphoglycerate. As just a changing position, there is no addition of any atom or molecule or deletion of any atom or molecule. Just changing position. So it is no other molecules are involved. You can just see the enzyme is nothing but mutase. We can just say phosphoglycerate mutase, or even if you are just writing mutase, it's okay. Okay, so phosphoglycerate mutase or mutase will be catalyzing this particular reaction. So we can see the reaction. We know that the 2-phosphoglycerate is OH, double bond O, C, CH, H, H, OH. We'll be just filling the phosphate later. The same thing, C, double bond O, OH, C, H, C, H, OH, H. So from this point, it is changing into the second compound. So you can see here, OPO3 2 minus, OPO3 2 minus. So from the third position, it is just changing into the second position. So that's about the step 8 of glycolysis. A mutation is happening catalyzed by mutase enzyme where 3-phosphoglycerate is converted into 2-phosphoglycerate. Now let us see the next step, that is step 9. Okay, so step 9. I am just writing in this way so that I can save this particular structure, but we have to make it down. Okay, so step 9. Step 9 is a kind of enzyme catalyzing reaction which belongs to the class lyase. We have learned about lyase. What is meant by the lyase? Lyase we have learned aldolase is a kind of lyase we have learned in stage 2. In the same way another lyase is coming. We know that lyase definition. The enzyme class which catalyzes the reaction where the molecules are breaking without involvement of water, or the double bond is inserted or deleted, okay, based on the removal or addition of molecules or atom. So that particular enzyme class is known as the lyase. That lyase class is coming again here. So you have to keep in mind 2 lyase class enzyme is there in glycolysis. What are they? Aldolase and the upcoming enolase enzyme. Okay, enolase enzyme actually catalyzes the step 9 of glycolysis, where the phosphoglycerate is turned into an enol form. A double bond is inserted between carbon number 2 and carbon number 3. As a result, it is changing into an enol form. Okay, so that enol form insertion, that's why the enzyme name enolase. So it is catalyzed by the enzyme enolase. So let us see the reaction. Here 2-phosphoglycerate is converted into phosphoenol pyruvate, and enzyme is enolase. Enolase enzyme catalyzes this particular reaction. 2-phosphoglycerate is converted into phosphoenol pyruvate. We will be just calling it as the PEP, phosphoenol pyruvate. So phosphoenol pyruvate is formed as a result of an insertion of double bond between the second and the third carbon of 2-phosphoglycerate, and it is catalyzed by the enzyme enolase. Okay, so let us see the reaction. I am just changing it back. You have to make it down. Okay, what is actually happening? I am just changing the color of this particular 2. HOH. As you are continuously writing, you don't have to make it. You can just mark below that. Okay, you can just put a line below that H and OH. As a result, what will be removed? HOH. Water is removed. So water will be going out. H2O is going out. Now what is left there? If this hydrogen is removed, this carbon will be having a valency free. If this OH is removed, this carbon also will have a valency free. As a result, this valency will be shared between these 2 and 3rd carbon, 2nd and 3rd carbon, and as a result a double bond is inserted. So that is what. So we can see the structure like this: COH, C, double bond C. I am just writing CH2. I am not explaining HH. Instead CH2 I am just writing, and there is OPO3. So it is changed into an enol form. Okay, so keep also this in mind. You don't have to write this H always. Instead, you can just write as CO minus double bond O. And more specifically, if you are more interested in chemistry, you can just write in this way. And this is actually representing the resonance. Okay. It will be, if this one is coming as O minus, this will be double bond. If this is coming as O minus, it will be double bond. Anyway, you don't have to go into details as you are learning the biology only, not chemistry. So keep in mind, this can be, as it is an acid, it can be donated. It can be in ionized form in physiological pH. So this is actually the phosphoenol pyruvate, PEP. Got it? What happened? Single. Water is removed. So to which and this class enzyme belongs? Enolase. It's a kind of lyase enzyme. Okay, it's a kind of lyase enzyme. Don't forget that. Clear? When you are learning something, you have to learn in the 3-dimensional or 4-dimensional way. Link everything here and there. then you will never forget the subject content. Okay, you will be enriching yourself with your subject content. So that is a way to enrich your subject content. You can just link whatever you are learning, link with the previous knowledge. Then both will be remembered forever. Okay, now we are just moving into the last step of glycolysis. That is the step 10. Okay, glycolysis step 10. I'm just keeping this, the result. We can just make it down. I'm just turning it into that side. Where the phosphoenol pyruvate is just converted irreversibly. The third step of third irreversible reaction in glycolysis is coming here, and that is the third rate determining steps in glycolysis. I will just say what is mean by the rate determining step. We know that other reactions are actually reversible. It can move in both directions. So that particular step will be, that means reversible step is actually controlled by equilibrium. That means if on both sides of the arrow mark the concentration of molecules are same, the reaction stops. If anywhere the molecule increases in its concentration, then the reaction will be proceeds in the opposite direction. For example, suppose 2-phosphoglycerate is there and the phosphoenol pyruvate. So if phosphoenol pyruvate and 2-phosphoglycerate is in same concentration, that particular step 9 will not be happening. Instead, if 2-phosphoglycerate concentration is increased, what will happen then? The step 9 will be proceeding into the phosphoenol pyruvate. So in this way, reversible reactions are controlled. But when we are taking the entire glycolysis, we can see that the entire glycolysis is controlled by the 3 irreversible reaction. Why? Irreversible means it cannot be going back. So it is not regulated by the equilibrium. Okay, so what will happen? Phosphoenol pyruvate is accumulating more and more. But as it is irreversible reaction, phosphoenol pyruvate will not be converted directly into pyruvate if your body decide to stop synthesis of pyruvate. So phosphoenol pyruvate accumulate. As a result, what will happen? Reverse reaction happen. Phosphoenol pyruvate will be converted into 2-phosphoglycerate, then into 3-phosphoglycerate, then into 1,3-bisphosphoglycerate, then into glyceraldehyde 3-phosphate. Then it will be accumulated there. As a result, the reaction will be stopping down. So in this way, the rate is controlled in glycolysis. Okay, so it is actually the rate determining step, the irreversible reaction. Hope you understood how the irreversible reaction and the reversible reaction works. Okay, so let us see the third irreversible reaction, third rate determining step in glycolysis, and the 10th or the final step in glycolysis. Here, the phosphoenol pyruvate. Okay, phosphoenol pyruvate is converted into simply pyruvate. Okay, so pyruvate is an example for keto acid. So PEP is converted irreversibly into a keto acid known as the pyruvate. What is meant by keto acid? The one which contains C double bond O. The one which contains C double bond O. Okay. So let us see the reaction. So what will be happening? Phosphate group, phosphoenol pyruvate is there. Now it's only pyruvate. So phosphate group is lost. If phosphate group is lost, who will be the one who receive this phosphate group? So we know that it is nothing but the ADP. So ADP will be accepting that particular phosphate group removed from phosphoenol pyruvate, and it will form ATP. And finally the pyruvate will be formed. Okay, so who will be the enzyme? Which enzyme will be catalyzing this particular reaction? Think in the opposite direction, and it will be pyruvate kinase. So kinase enzyme will be there. Now, this is an example for what kind of phosphorylation? We have learned it. We are learning that kind of phosphorylation in glycolysis. Total 3 incomplete oxidation of glucose. So what kind? We have learned the previous ATP forming step. At that time we have learned about one kind of substrate level phosphorylation. What is that? It is nothing but the substrate level phosphorylation. Substrate level phosphorylation. Substrate level phosphorylation. Why? Because the substrate other than ATP is acting as the donor of phosphate group. Okay. So phosphoryl group transfer potential is retained in the substrate other than ATP, and as a result from substrate into the ADP phosphoryl transfer happens, and as a result ATP is formed, and such reactions are known as the substrate level phosphorylation. So this particular step is an example for substrate level phosphorylation. Okay, so phosphoenol pyruvate is changing into pyruvate. So let us see the reaction. Kinase is enzyme, don't forget that ATP will be formed. So how many ATP? You don't forget, everywhere here 2 only. So 2 phosphoenol pyruvate, 2 ADP, 2 ATP, 2 pyruvate. Don't forget that after the stage 2. From stage 3, entire molecule will be 2 in number because glyceraldehyde 3-phosphate is 2 formed in stage 2. So C, I'm just writing the ionized form, double bond O, then C, double bond O, okay, C double bond O and CH3. This is the one known as the pyruvate. This is the one which is known as the pyruvate. Now the question is, from where this particular H3, the third hydrogen, came? It is nothing from ADP terminal phosphate OH is there. When it is getting ionized to O minus, that H will be there and that H will be coming here. Okay, so if you want to understand better, you can just make it like this, or H, H and this H, so that you will understand it is actually coming from this ADP. And this also you can just make it as the O, because this O is retained there in that. But actually you can see that a water molecule playing will be happening here. Okay, you don't have to go into details of that. It will be creating more confusion in you as you are in degree program. You have to learn up to this only. Okay, so this is actually what happens during the glycolysis. So the final step is the ATP is formed. Clear? So let us revise the concept with the energy balance sheet. Now let us see the energy balance sheet of glycolysis. Before that, just recall glycolysis. It happens in 3 stages. The first stage is trapping and conversion of glucose into cleavable form. Second thing is the cleavage and the formation of 2 molecules of glyceraldehyde 3-phosphate due to isomerization. And the third stage is the conversion of glyceraldehyde 3-phosphate into pyruvate with the release of energy in the form of 4 ATP molecules and 2 NADH plus H plus molecule. So the 3 stages are over. In this particular glycolysis, there are 3 irreversible reactions. The first one is the first reaction where glucose is converted into glucose 6-phosphate. Second one is the third reaction where fructose 6-phosphate is converted into fructose 1,6-bisphosphate. And third irreversible reaction or rate determining step is the last step, the 10th step, where phosphoenol pyruvate is converted into pyruvate. In glycolysis, 2 substrate level phosphorylation happens. One in the conversion of 1,3-bisphosphoglycerate into 3-phosphoglycerate. where 2 molecules of ATP are formed. And second is there in the conversion of phosphoenol pyruvate to pyruvate, where 2 molecules of ATP are formed. Okay, actually speaking, one reaction will be creating only one molecule, but in glycolysis 2 molecules are involved. As a result, 4 ATP are formed. So that's about the briefing of glycolysis. Make sure that you are learning this properly, because this will be one of the questions for essay, 8-mark question.